Have you ever thought about what would happen if the medicines we rely on simply stopped working? It sounds like something from a science fiction movie, but it's a real problem happening right now, all over the world. We are facing a silent pandemic, one that doesn't always make the headlines but is just as dangerous. This threat is called antibiotic resistance. Bacteria evolved to survive the drugs designed to kill them. These super strong germs are often called superbugs. Each year, these superbugs are responsible for millions of deaths, and that number is projected to grow if we don't find new solutions. It's a global health crisis that affects everyone, everywhere. It turns common infections into life-threatening emergencies. The danger is that antibiotic resistance undermines much of modern medicine. Think about medical procedures that rely on antibiotics to prevent infections, surgeries, simple appendix removals, complex heart transplants. Cancer treatments like chemotherapy weaken the immune system, making patients highly vulnerable to infections. Without effective antibiotics, those treatments could become too dangerous to administer: a scraped knee, a sore throat. The safety net antibiotics provided for nearly a century is beginning to tear. You see it every day in hospitals around the globe. This problem didn't happen overnight. For decades we've used, and sometimes overused, antibiotics. Every time we use an antibiotic, we give bacteria a chance to learn and adapt. The strongest bacteria survive and multiply, passing resistant traits to the next generation. It's evolution in fast forward, inside our bodies and in the environment. We've been locked in an arms race with microscopic organisms. Recently, we've been falling behind. We haven't discovered a truly new class of antibiotics in decades. We've mostly modified old drugs, while bacteria develop new defenses. This is why the search for new antibiotics is one of the most urgent missions in science today. We need new tools to fight these evolving threats. The challenge is enormous. Finding new drugs is slow, expensive, and difficult. Scientists must screen millions of chemical compounds to find just one candidate. Even then, success is not guaranteed. But what if we could make that process faster, smarter, and more efficient? What if we had a partner that could analyze information on a scale far beyond human capability? This is where a new hero enters the story. Artificial intelligence, or AI. It's a powerful tool that's giving scientists new hope in this critical fight for our future. So, what exactly are these superbugs we keep hearing about? They are not a new type of creature, but rather familiar bacteria. Staphylococcus aureus, which causes staph infections. Neisseria gonorrhoeae, that have undergone a dramatic transformation. Through tiny changes in their genetic code, they have built up defenses against the antibiotics we've used for years. Imagine a castle that keeps adding stronger walls, higher towers, and deeper moats. That's what these bacteria are doing on a microscopic level. They can develop ways to pump the antibiotic out of their cells. In the face of this daunting challenge, a team of brilliant researchers at the Massachusetts Institute of Technology, or MIT, decided to try something completely different. This team, led by scientists like James Collins and Regina Barzilay, brought together experts from different fields: biology, chemistry, and computer science. Their big idea was to harness the incredible power of artificial intelligence to supercharge the search for new medicines. They believed that AI could do what humans couldn't: rapidly analyze vast amounts of chemical data to identify compounds with bacteria-killing properties. Instead of relying on a scientist's intuition, or painstakingly testing chemicals one by one in a petri dish, they decided to build a digital brain. This AI model could be trained to recognize the specific molecular features that make a compound effective against bacteria. The team's goal was ambitious: to create a system that could not only find existing chemicals that might work, but could also help them design entirely new molecules from scratch. The result of their groundbreaking work was the creation of two new, powerful antibiotic candidates, NG1 and DN1, DN. So, how did the AI actually find these new drugs? Think of it as training a digital detective. First, the MIT researchers had to teach the AI what to look for. They fed it a huge data set of thousands of chemical compounds. For each compound they labeled whether it stopped growth of E. coli. The AI, a deep learning network, analyzed all the data and learned to connect a molecule's structure with its ability to kill bacteria. It learned to spot subtle patterns and chemical features humans had missed. Once trained, researchers set it loose on vast digital libraries containing millions of chemical compounds. In minutes it sifted through them, evaluating each molecule and predicting which would work against bacteria. Finding a promising molecule on a computer screen is one thing, But proving it works in the real world is the most important step. When the researchers tested NG1 on samples of Neisseria gonorrhoeae in Petri dishes, they found that it was highly effective at killing the bacteria. In a series of experiments, the team tested DN1 against MRSA in 2 different mouse models of infection. In both models, DN1 was able to significantly reduce the amount of MRSA bacteria in the mice within just 24 hours. The journey from a promising compound like NG1 and DN1 to a medicine you can get from your doctor is long and complex. If the preclinical tests continue to be successful, the next major milestone will be human clinical trials. Beyond these specific antibiotics, the success of this AI-driven platform opens up a universe of possibilities for medicine. Imagine using AI to find new antiviral medications, new therapies for cancer, new treatments for Alzheimer's. Ultimately, this breakthrough from MIT is about more than just 2 new potential drugs. It's about a fundamental change in how we approach science and health. It shows us that by combining human creativity with the power of artificial intelligence, we can solve problems that once seemed insurmountable. The fight against superbugs is far from over, but we now have a powerful new ally on our side. This is a moment of incredible promise, a time when technology is not just changing our lives but giving us the tools to save them. What role do you think AI will play in the future of our health?